Over-rotation of the spine is proven to be a major cause of spinal fractures, spinal cord injuries, and paraplegia. Most back protectors are designed to guard against only direct impacts. The team at Edera Safety will give you insights of how they combine generative design and intuitive design methods in order to create a new and revolutionary spine protector. Please welcome Adam Saier. Thanks. Good luck.
Thank you. Well, I think let's start with a quick insight into our studio with a short video.
Team Adams4 is committed to prevent spinal cord injuries. The approach of our team is to develop something like a second skin device.
The structure that Generative Design produced for us was used to create a more efficient and better working back protector.
Autodesk software and Fusion 360 gave us a big advantage in the development process.
What we are trying to do in the future is to use generative design as a constant tool in order to improve our products.
So basically, Edera Safety is an interdisciplinary design studio, theme open, and our aim is to reduce time to market periods. And within the next keynote, I'd like to explain to you how we actually combined industrial design and electronics in order to create a new spinal protector. And the presentation is based actually on 3 pillars. I'm going to give you an insight about the background of spinal cord injuries. And afterwards, we're going to take a look at the intuitive design process versus a generative design process. So let's start with the spinal cord injury. Well, every year around more than 500,000 spinal cord injuries occur worldwide. And beside all that physical and psychological stress that occurs, there even occur huge socioeconomic costs. For example, in the UK, a study has been published that shows that in 2016, around 1,300 cases of spinal cord injuries occurred. And this led to estimated treatment costs around 1.6 billion euros. So our aim is actually to prevent such consequences. And if we take a look around back protectors and their efficiency, you can see that there's actually 2 ways how to injure your spine. One way is what we call the so-called direct impact. That means you fall against something locally and this penetrates your spine and damages it. And the other huge part, more than 96%, is caused by what we call biomechanical impacts. So that could be either compression, distraction, or rotation. But the likeliness to get a spinal cord injury raises from compression to rotation exponentially. That means that existing back protectors have actually an efficiency of less than 4% statistically. And our aim was to think about if we could actually focus on rotation and add this specific feature to an existing back protector, we could actually maximize the efficiency. So let's talk a bit about the biomechanics of the spine. There are a lot of engineers here in this room, so I'd like to explain the spine this way. The spine actually consists out of 3 segments: a cervical spine, your thoracic spine, and your lumbar spine. And there are specific points which are very likely to get injured. In this chart, you see from the top to the bottom all vertebrae, and you can see pretty clear from left to the right that wherever the transition between your thoracic and your cervical spine, or either the thoracic and the lumbar spine is, there is a massive peak of injuries. And that's because the spine kind of works like a chain. Imagine if you have a chain in front of you and you block a few segments. So the first segments, which are dynamic, are actually most likely to break. So basically, the challenges that we were facing as soon as we have recognized this briefing, we have seen, we tried to evaluate our designs. And the problem was that there were no studies about biomechanical vertebral resistance back then. There were even no physical evaluation methods that we could use. For example, automotive crash test dummies are not able to rotate their upper or lower body. And according to that, there were even no virtual simulation methods because the E-modules have not been identified back then. And that's why actually we had to start a collaboration with the Medical University of Graz, the Medical University of Vienna, and Wings for Life in order to gain this data at first. And based on this information, we were designing specific test beds. What you see here is actually the latest test bed that we were launching a few weeks ago, on which we were testing rotational injuries. Let's get to the design process. So this was actually the foundation of the project where we said, okay, we have a good way how to evaluate the design. And right now we have to think about how to design the product. So basically in 2017, we started intuitively. Within a 4-month period of time, we were actually developing around 125 intuitive design concepts. And this consumed around 1,300 hours of working time. But the challenges here actually were that it was extremely time-consuming, and in such a complex briefing, such as the vertebral, such as your spine is, all results are actually based on intuition. And that's why we decided we want to learn more about the body using generative design. In the beginning of the project in 2018, we started to perform a few topology optimizations in order to get an idea how the structure of the spinal cord protector could look like. But the problem with simulations is always that a simulation is only as good as the constraints are. And that means we had actually not much clue about the constraints, because what you've seen before in the test bed, that it's such a one-dimensional movement, but as soon as it gets to sports, it's getting really three-dimensional. So we decided to implement a hardware-in-the-loop design process. That means, inspired by the project from the Bandito brothers of Autodesk, we wanted actually to develop a protector which works like a test system and a measuring system, which can earn and raise data, which then can be looped back into generative design in order to optimize the structure. So what we did at first, we recruited specific team riders in specific sports just to get like a wide range of motion, like the widest one as possible. That's why, for example, Red Bull crashed ice-leads were there, freestyle motocross, mountain biking, and unicycle downhill mountain biking as well. And what we did, we equipped these guys with the measuring system and took them out on the field and let them test the device. And what you see here are actually the tests that we performed in Austria, close to our studio. And this is actually the very first measuring device that we did in 2017. Afterwards, we had to redefine and optimize the device. We even had to develop a specific app to have like the device mobile. And you can see here on the app that it actually tracks all the range of motion in the specific sports. So basically what this measurement system does is it tracks the movement between your upper body and your lower body. And as soon as you have an impact in the center of the force in the field, there's even like a force sensor implemented which measures the force. So as soon as we had our first data, we were starting to loop it back into generative design. And based on this, you can see that our structures actually started to grow. We actually combined this with our intuitive design processes. So our designers were actually focusing and taking a look at the studies and at the proposals, and then we used specific segments to translate them into a product. What's interesting is that as soon as we started the generative design simulations, within around 48 hours, we approached 190 design concepts. So you can see that there's a huge difference in generating things instead of doing it all intuitively. And driven by all these concepts, we started to merge actually these simulations into the product, as you can see right here. So basically what the product is doing, it is actually a device which allows your natural range of motion, which is caused by your active movement. So we divide between active and passive movement. Active movement means all kinds of movement if you rotate your spine with your muscular system. And if you're, for example, relaxed, you can move your spine even further. And that's actually the critical range where our device needs to start absorbing forces. So in this chart here, you can see from left to right, the green zone, which is your active motion zone. In the middle is actually the zone where the device needs to absorb forces. And on the red zone, we definitely know that an injury occurred. And this is actually a chart on a test bed, which has been performed a few weeks ago, where you can see that the device really starts to take on a lot of load starting from this critical area. All right, so summing it up in terms of a forecast. We believe that using generative design is a huge tool to rapidly explore the design space. You can even rapidly generate IP. And what we are really looking for is to have in the future a brand which is fully automated, machine learning, the generative design software. This would be maybe enabled with an API in the future. And as a studio, we are definitely interested in creating new benchmarks in fast design processes, theme open. So I'm pretty much at the end of this presentation. Finally, I have to thank my team because such a huge project would not be able to be done with a great team. So to all my guys at home. And if you are interested in having a conversation afterwards, or even maybe a cooperation, just let me know. Looking forward to our discussion. Thank you so much.